Today we are going to discuss about the suspensions and colloids. Remember, we had a discussion regarding the concentration of the solutions, how to measure. There we have seen mass by mass percentage. We have seen mass by mass percentage. I think you can remember. We have done mass by volume percentage also. We have done some calculations regarding both of these. Now we have come to the point when we have got to move on. We are going to discuss about suspensions and colloids. So first thing first, let us discuss about suspensions. So all of you, let us write down the definition of the suspensions. Suspensions are, whether we should write a suspension is a heterogeneous mixture in which very fine particles whenever we are writing very fine, we should be very particular about size of 10 to the power minus 7 meter or more of a solid are dispersed in any medium that any medium can be liquid or gas. Now one more thing one must remember that in any suspension, fine particles of solid remain suspended in a medium. So that is what is all about the suspension. I am just giving you a few examples which will give you a better idea. As an example, you can say the muddy pond water, or you can take the examples of the smoke coming out from chimney of an industry, or not only industry, anywhere actually. So you must have seen in these cases, muddy pond water, what happens, small particles of this diameter or more of solid are dispersed in the medium. In this case it is liquid, in this case it is gas. So now let us see that this is the suspension. Regarding suspension, according to our syllabus, there is not much of a discussion beyond that, but we are going to discuss about colloids, where the discussions will be in little bit more details. So let's see. Now let us discuss about some of the properties of suspension. So then we are going to discuss about colloids. So this is about the properties of suspension. So let us discuss about one by one. The properties first I am writing, then accordingly I will talk about it. First one is heterogeneous nature. Next one is visibility. Third one is particle size. Fourth one is sedimentation. All of you write it down. sedimentation, and the fifth one is separation by filtration. Okay, so let us talk about this one by one. First of all, heterogeneous nature. You know what is heterogeneous property? The heterogeneous property means the chemical or the physical properties are not same throughout. So obviously suspension is a heterogeneous system. Now visibility. We have seen that in case of homogeneous solution, you just cannot see the solute and the solvent separately. But the particles that is present in the suspension, you can see with naked eye, or if it is not possible with the naked eye, then definitely with simple microscope. So either with this or with that, you can see the particles present. So particles are visible. Particles can be visible through either naked eye or by this. Now then is the particle size. So we know that particle size means we are talking about the radius of the particle, which should be 10 to the power minus 7 meter or higher. Now sedimentation. What is a sedimentation? The particles in a suspension should have a tendency to settle down. If it is very fine particles, then only it will remain suspended in the medium. So the tendency to settle down, this is called sedimentation, and that tendency is there in case of suspension. Then is the filtration. We know that in case of solution you cannot separate them by filtration, but in case of suspension, larger particles can be separated by filtration method. So this is about the properties of suspension. Next topic will be, as I was telling earlier, the colloids. Now regarding colloids, remember in class 12, again the discussion will be reopening, but here we will have a minimum idea or the preliminary idea about the colloids. So let us see what are colloids. Once you have understood what is a suspension and once you have understood what is a true solution, the understanding of colloids becomes easier. So here we are discussing about colloids. So actually it is a homogeneous looking heterogeneous mixture. So this term is used, homogeneous looking heterogeneous mixture, where you are having particle size between, where the particle size is in between 1 nanometer to 100 nanometer. Now we must understand that nanometer means it is 10 to the power minus 9 meter that we are talking about. So earlier we have seen the particle size for suspension. Now we are observing the particle size for colloids. And colloids, these are commonly known as salts. These are commonly known as salts. So this is the basic definition of colloids. It looked homogeneous, but actually it is heterogeneous in nature. Now, in the medium, the colloid particles are actually divided into two phases. One is, two phases means, earlier we have seen in case of solution, one is it is made up of two things, solute and solvent. Here also there are two things. One is dispersed phase, okay, another is dispersion medium. Now, suppose, what is a dispersed phase? Dispersed phase means the continuous medium on which the particles are present. So these are the particles which are present, and this is the continuous medium in which particles are present. What does it mean? Just remember the case of solution. In case of solution, this quantity or the content that is present in lesser quantity, that is called as solute. Here also, similar to that, that is known as dispersed phase. So you can correlate dispersed phase with that of solute, and dispersion medium you can correlate only, not the same, okay? So you can correlate that with the solvent. Now, after writing this, if I write dispersion medium, in some of the book now, this is also written as 1 nanometer to 1000 nanometer. In higher level books you will see this. So both are correct. I mean, this is more correct. Suppose we take fog, if we take liquid sprays, the sprays that we use, there you will find the, suppose these are called aerosols, right? Here you will find dispersed phase as liquid and dispersion medium as gas. If you take the example of smoke or dust, there you will find the dispersed phase as solid, dispersion medium as gas. If you take foam for an example, in case of foam, this one becomes gas and this one becomes liquid. Another very easy example, if you take, in case of foam, it means like soap water, soap lather rather. Suppose we take milk. In case of milk, what happens? It is a kind of emulsion, you can say. Both of them are liquid. So similarly, there are various examples given in the book. What I am trying to say is that there are various type of combinations of liquid gas, solid gas, gas liquid, liquid liquid, and all this comes under this category called colloids. Now, after observing colloids, we are going to discuss about the properties of colloids. So let us see, the next topic will be the properties of colloids. So let us talk about the properties. Let us talk about one by one. So, firstly, I am just writing down the points. First one is heterogeneous nature. Second one is particle size. third one is the separation fourth one is stability, fifth one is Brownian movement, and last one is, you can say Brownian, along with the Brownian movement there is another one called Tyndall effect, and there is another term called electrophoresis. So these are all the important properties of the colloids. Now let us talk about them one by one. These two are very, very important regarding the exams. Let us talk about the first one, which is the heterogeneous nature. We know that colloid can only be seen through powerful microscopes. So they appears as homogeneous nature. So colloid particles are only visible through a powerful microscope. So earlier it was not required. Remember, in case of suspension, this powerful microscope was not required. Through simple microscope we can see, or with the naked eye also we can see. In the particle size, as I have said, it is particle size should be between 10 to the power minus 9 meter to 10 to the power minus 7 meter. Separation. See, with the filter paper you cannot separate. So it cannot be separated by the simple filtration. With the simple filtration method, you cannot separate this. What you can say is the colloidal particles. So you need something better to separate them. Now, if we are talking about the stability, these are usually unstable. You do not expect them to be as stable as the solution. So colloidal particles are usually unstable. If you can use a suitable stabilizer, what is that at class 9 we are not going to discuss. Just remember, they tend to settle down. Usually they used to settle down, but only if stabilizers are used, then only they are stable. So usually they used to settle down. Now these two topics we have to discuss separately. So if you have written it down, I will just erase. Now let us discuss about this very important topic known as Brownian movement. In case of Brownian movement, what happens? Say for an example, if you observe the colloidal particles under a microscope, suppose these are the particles. So suppose there are 4 particles. So they will have random zigzag motion, like this will come here, then it will go here, then it will come here, again, like this. So everywhere the particles moves around. like this. The particle moves around in this fashion. Okay, so this is about one particle. Another particle can also move around like this. This is the way they move around. This zigzag movement is known as the Brownian motion, named after the scientist who has discovered it. So it's a very, very new thing. So we have not discussed something regarding this earlier. Then called the Tyndall effect. Next is Tyndall effect. This term Tyndall effect is like, suppose you take pure water here, and if you are passing a light with a torch, if you are passing a light, suppose these are the light rays, it will go through this. Now in this region, the light beam is not visible. You cannot see anything. But if you take a colloidal solution, suppose this is a colloidal solution, and similarly if you have taken a torch here and if you are passing the light beam through this, what happens is, through this region here, the path of light beam is visible. And this is a speciality. The path of the light beam becomes visible because the true solutions do not scatter. So they do not show the Tyndall effect. Remember, there is no scattering here. No scattering. But here the scattering takes place. That is why the path of the light beam becomes visible. So electrophoresis you read by yourself. We are going to discuss it on the next video. You think about it, read about it. If there are questions, you comment over here under this video. Go through it, then only we can go for the next topic. These are very, very important things. Properties of colloids regarding the examination is a very, very handy topic. So this is what we had to discuss. Write these things down at the time of examinations. Draw these diagrams to make a better impression. So this is it.